Hey guys, so today we're going to be talking about absolute value inequalities. Hopefully you already watched the other videos that you already have a brief understanding of this. I do want to go over it just one more time to make sure you're getting it. But really, if you watch the other video, you should already kind of be thinking about number lines, right? So we want to briefly go over the rules and talk about them one more time. So first thing we want to talk about is if you have the absolute value of something is greater than C, okay? Or greater than some number, right? So if you have a greater than inequality, you are going to have an or situation, okay? One way I always tell my students kind of trick is if you have greater, right? Greater, it's kind of like an or. I don't know. If that helps you, it helps you, okay? So greater, or it could be greater than or equal to, that's going to be your or statements, okay? So if you're thinking about this on the number line, like he showed us earlier, right? Then you know what's inside of our absolute value, okay, has to be greater than C away from 0, right? Or the absolute value of our negative C could be what was inside of our absolute values needs to be less than negative C, right? So those are going to be your two inequality statements, right? If you notice the difference here, your first one is the same as our original inequality we were given, but we took away the absolute value bars, right? Your second statement is almost the same, right? You drop the absolute value bars, they're no longer there. This part doesn't ever change, what was inside the absolute values. But our sign flipped. It went from greater, right, to less than. And then our C also changed from a positive to a negative. So I guess that's our rule here. Your inequality is going to flip. And then the side that was not inside your absolute value bars, that's going to change sign. Okay, and then our second rule we have down here, when you know the absolute value of something is less than some number, okay, that's going to be our and inequalities. So with our and inequality statement, remember, you can also write them as one single statement, just like we have down here below, okay? Same rules as above apply down here, okay? So your first statement, you're dropping the absolute value bars, right? And then our second statement is you drop the absolute value bars, the part inside stays the same, but once again, our signs flip. So our original was a less than. Our second one, we flip it to greater. And then our C goes from positive to negative. Okay? But once again, you should always think about it on the number line. It helps you actually understand what you're doing and not just trying to memorize rules. Okay? But remember, with and inequalities, you can write them as one inequality statement like we have here. Okay? So let's look at our first example down below. All right, so first things first, with absolute value, you always want to isolate your absolute value. So here's our inequality. That's always what's going to separate our left side from our right side, okay? If you notice on our left side, our absolute value is not isolated. It's not all alone on this left side. We also have this plus 4. Okay, so first thing we've got to do is isolate it. So to cancel out a plus 4, we're subtracting 4, right? 4 minus 4 is 0, so we have the absolute value of 3x minus 6 is less than or equal to 16 minus 4 is 12. Okay? Now our absolute value is isolated. It's all alone on this left side. So now is when we want to start thinking about what this would look like on the number line, or thinking about our rule So we're thinking about what type of inequality we have, right? All right, so let's think about it on a number line for a second, like you were listening to earlier. Okay, so on a number line, we're thinking about the absolute value of 3x minus 6 needs to be less than or equal to 12, meaning it needs to, the distance it needs to be is less than or equal to 12 from 0, right? So here's 12 away from 0. We want whatever this absolute value is to be less than, okay, or equal to. So we could color in 12. It would need to be equal to 12, or the distance it is from 12 needs to be less than 12, right? I mean, the distance it is from 0 needs to be less than 12. Sorry. Okay? But we know that negative 12 is also 12 away from 0 when you take the absolute value. So it could also be equal to negative 12, or it could be anything greater than negative 12, okay? Because when you take any of these numbers in between negative 12 and 12, all of these numbers, anything less than 12 and anything greater than negative 12, satisfies both of those. Those are all 12 units away from 0 or less than 12 units away from 0, right? If we chose the number negative 5, if I take the absolute value of negative 5, we know that's 5. Okay, because negative 5 is 5 units away from 0. And negative 5 or 5 is less than 12. Okay, so that satisfies our condition, right? Okay, sorry. I moved our number line over so that I could have room to work down here. But remember, this is not our solution. This is just helping us understand how we're setting up our two separate inequality statements, right? So the first one we need, okay, is we need 3x minus 6 to be anything less than 12 or equal to 12. Less than or equal to 12. Okay. And then our second one would need to be 3x minus 6. Remember, you never change what's inside the absolute values. Oops, on here. You never change what's inside your absolute values. So we kept this one basically exactly the same, but we dropped our absolute value bars, right? For this one, we also need it to be anything greater than negative 12. Greater than or equal to negative 12. Okay, so since we could shade in the middle, right? We wanted everything in the middle of these two. You can tell it's an and inequality, right? So if we're looking at our and rule up here, right? You can see that it's when you have the absolute value of something is less than some number. So here we had less than or equal to some number, right? And the only thing that changed between these two inequality statements is the signs flip. And then you also change the positive 12 to a negative 12. Okay? And now we're going to solve. So we would add 6 to both sides, because remember we're trying to get our x by itself. So we have 3x is less than or equal to 12 plus 6 is 18. Divide both sides by 3. And we get that x is less than or equal to 6. Okay? Same thing over here. Getting x by itself. So we're adding 6 to both sides. We have 3x is greater than or equal to negative 12 plus 6 is a negative 6. Divide both sides by 3. And we get that x is greater than or equal to negative 6 divided by 3 is a negative 2. Okay? So those are our two answers. And we can put those on a number line, right? So we'll have negative 2 somewhere over here, 0, and then we'll have 6 somewhere over here. Negative 2 is greater than or equal to, so I'm going to color in that circle, okay? x is less than or equal to, so I'm going to color in the circle at 6. If I want all of the values that are less than 6, means I'm shading to the left, but they also have to be greater than -2. Okay, so we're shading in the middle there, just like we do for and inequality statements. And since this is an and inequality statement, we can write it like this, right? So we have our -2 needs to be less than or equal to x, and then x can be less than or equal to 6, right? So this one basically stayed the same, and then we had to flip this one around, right? We flipped our -2, flipped our inequality, and flipped our x, and just kind of tacked that on over here, right? So this would be your answer. This is also a way to write your answer, or obviously looking at it on the number line. All right, so another way I want to look at this is, before we were talking about the rules, we said if you have the absolute value of something is less than or greater than some number, right? Well, if you'll notice with this example, your absolute value is on the right side instead of the left side, like the ones we were looking at before, right? Is there anything wrong with that? Absolutely not. Okay? If you're someone that likes to keep things consistent and you like to solve it how you've been solving it and how you're comfortable with or familiar with, then we can rewrite this, okay? So all we have to do is just flip everything, okay? So we're going to switch the right side to left side to the right side, but that means we also need to flip our inequality, okay? Because the smaller part of your inequality, the closed part, still needs to point to your 8, and the open part of your mouse still needs to point towards your 2 plus absolute value of 5 plus m, okay? So I'm going to flip this whole side to the other side. 2 plus the absolute value of 5 plus m, okay? We want the open mouth facing this side, so it needs to be greater than. We flipped our inequality, and then we're going to flip our 8 to the other side. Okay, and then it looks like something you are used to seeing, right? So from here, we have absolute value. We always have to do our first rule, which is isolate that absolute value, right? So to isolate our absolute value, we need to cancel out this 2 that's not inside of our absolute value signs, right? 2 is being added to our absolute value, so we're going to cancel it out with addition or subtraction. Since 2 is positive, the way to make it go to 0 is to take 2 away. We're going to do that on both sides. So I'm left with the absolute value of 5 plus m is greater than 8 minus 2, which is 6. Okay? Now from there, we want to set up our 2 statements, our 2 separate inequalities, okay? So we can think about this on the number line again. Okay, here's 0. We want whatever 5 plus m is to be greater than 6 units away from 0, okay? So here's 6. I want whatever this equals to be any number that's greater than 6. Okay? From this, you should already kind of be able to see that this is going to be an or inequality statements because we're shading away from 0 basically, right? Because that also means whatever's in here needs to be 6 units away. Means we could also use, oops, let me make that focus. There we go. Could also be -6, right? Because the absolute value of -6 is 6. -6 is 6 units away from 0, right? And we want greater than 6 units away from 0, meaning we would need to choose all of the numbers less than -6, okay? Because if we chose a number over here, say I chose -8, right? -8 is 8 units away from 0. 8 away from 0, we know 8 is greater than 6, right? So that would satisfy what we want here. So this is going to help us write our two separate inequality statements, okay? So remember, you could also tell from the sign, we have a greater than sign, greater, or, right? It's going to be that or inequality, okay? So our two separate statements. First one, we're keeping it exactly how it is, but we're dropping the absolute value bars. So 5 plus m needs to be greater than 6, right? That's what we have here. Needs to be greater than 6. And then our second one, 5 plus m, needs to be less than -6, right? So we flipped our inequality sign and we changed the 6 to a -6. And then from there, we just got to solve. So we're going to subtract 5 from both sides to get that m by itself. We're canceling out that +5. So I have m needs to be greater than 6 minus 5 is 1. Same thing, subtracting 5 from both sides. So we have m is less than a broke my lead. Less than a -11. Okay, so those are my two answers. If we put this on a number line, okay, we have -11 over here, 0 and 1 over here. Neither of these are or equal to, okay, so they're both going to get open circles. I want any m value that's greater than 1. So I'm shading to all the greater than 1 values. And then any m that's less than -11. So I'm shading to all the smaller values that are less than a -11. Okay, so this is an answer. Or since this is an or inequality, this would also be your answer. All right, so then this last example, we have the absolute value of y plus 3 divided by 6 is less than -2. Okay, so let's look at this. First thing always we need to do with absolute value inequalities or equations, whatever we have, is we always have to isolate our absolute value. So to do that, we would need to cancel out this divided by 6. And we know to cancel out a divided by 6, we do the opposite and we multiply both sides by 6. Okay, so 6 divided by 6 cancels out. So we're left with the absolute value of y plus 3 is less than -2 times 6 is a -12. Okay, if you'll notice or remember from the video I posted about special cases, right? The absolute value of anything is always going to be a positive number because absolute value is the distance away the distance something is away from 0, right? You can't be negative distance away from 0 or negative distance away from anything, right? So to say that the absolute value of something needed to be less than a negative number, it's not possible, right? The absolute value of any number is going to always be positive, which would mean this would be no solution.